Now for this question, let Sn is equal to the summation of -1 to the r minus 1 r square from r is equal to 1 to n. We need to use the standard result for the sigma r square with r from 1 to n given in the list of the formula sheet to show that S2n is equal to minus n into 2n plus 1. Now, the first thing I notice here, this is an alternating series. Now, we can identify some terms here by starting with r is equal to 1. If I put r is equal to 1, I'm going to get minus 1. 1 minus 1 is 0. 1 to the square is 1 square. Then plus, again minus 1. And then this is now r is equal to 2. 2 minus 1 is 1. And then 2 to the square. Alright, plus I've got minus 1. Okay, now r is 3. 3 minus 1 is 2. And then I've got r is 3. And I've got 3 to the square. And now this is going to go on like this. And what I have is 1 square plus 2 to the square. I mean, this is power 0, power minus 2, so this is plus minus, okay. And then plus 3 to the square, minus 4 square, plus 5 square, minus 6 square, plus and so on. And this is basically minus. So we've got them some odd terms minus the even terms. All the even terms are negative, so we're going to take odd terms minus even terms. So what are the odd terms? The odd terms are 1 square plus 3 to the square plus 5 to the square and so on. Take that minus the, we're going to take the sum of all of that minus the sum of the even terms. So 2 square plus 4 square plus 6 square plus 8 square and so on. So what we're saying is that summation with r going from n, from 1 to n, and then this 1 minus 3 is 2, 3 minus 5 is 2, 5 minus 3 is 2, so the difference is 2 here, so I've got then 2r, and then minus 1, okay, to the square, minus, how do I get that minus 1? Now, from here to here we've got 2, then I've got 1 minus 2 is minus 1, okay, you take the first term here, you minus the common difference, and you get minus 1. You can test this into this to find out if this is okay. For example, the third term, 2 times 3 is 6, 6 minus 1 is 5, and here we got 5. And this one is 2 to the square, so 2, 2, 2, because 2 plus 2 is 4, 4 plus 2 is 6, so the common difference is 2, and I've got 2r to the square. And then this is going to be from n is equal to 1 to n, I mean from r is equal to 1 to n. Now we can expand this. I'm going to get 4r squared minus 4r plus 1, the summation of all of that. Okay, subtract here the summation of 4 square. I mean 4r squared. Now this is 4r squared, so I can say 4 sum limits, I mean from r to n, r squared minus 4 sum to 1, and then I've got n r plus r minus summation of 4r squared, okay, r going from 1 to n. 4r squared can cancel out, and I'm left with minus 4 times the summation of, what's the summation of r? Now summation of r from the list of formula, you can check in the sheet, it's going to give you 1 over 2, alright, n, okay, into n plus 1, and then plus r, and r is basically n, so this is 2n minus 2 n into n plus 1 plus n. And from here I've got minus 2n squared minus 2n plus n. Right, and again we can simplify. Minus 2n plus n is minus n, so I've got then minus 2n squared minus n. If I were to factorize this, I'm going to get minus n outside into 2n plus 1. And I think this is it, because that's what we've been asked to prove. So hence the proof. That's been proved. Here we are for the first part of the question. Now moving on to the second part of the question. State the value of limit with n going to infinity of s2n over n squared. And also find the limit with n going to infinity for s to the sub of 2n plus 1 over n squared. Let's deal with this one first. Okay, so now what is s2n? We did find that s2n was here in the question, right here. This is s2n. Basically we're saying this, alright? So now we've got then minus n into 2n plus 1. And we have to divide by n squared. So we divide by n squared. If you cross this out, you minus 1 here, you're going to get minus 2n plus 1 divided by n. So again, that's minus 2n divided by n, which is then minus 2. And then plus minus becomes minus. 1 over n is 1 over n. Now, if we look at this carefully, as n approaches infinity, if we a large value of n here, then we have negative 1 over n is going to approach 0, because this has become larger and larger. 1 divided by a very big number is going to approach 0. Therefore this is 0, so we have then minus 2 plus 0. Therefore the answer is going to be equal to minus 2. Now for the other part, that is this one, we need to deal with the numerator first. Okay, so s2n plus 1. This is basically s2n plus 1. 1 of this whole thing here. So this is the minus 1 to the r minus 1. So minus 1 to the r minus 1. And then r squared. So we got then r squared. So what we're saying then, s2n plus minus 1 to the r minus 1. Now remember r is 2n plus 1. Okay, so we got then 2n plus 1 minus minus 1. R squared, and again r is 2n plus 1 to the square. So we've got then s2n plus, this is going to cancel out, and I've got minus 1 to the 2n, okay, then times 2n plus 1 to the square. So s2n, this is basically positive now, because any number multiplied by 2 is going to give you an even value. So even, that's going to be plus minus, and then this becomes plus. So we've got then plus 2n plus 1 to the square. What is s2n? We did find s2n was minus n into 2n plus 1, okay, and then plus 2n plus 1 squared. Now if we simplify this, we are going to get minus 2n squared minus n, okay, plus you can say 4n squared plus 4n plus 1, and again this minus, that's going to be 2n squared plus 3n plus 1. Now when we come here, remember we have to divide by n squared. So if I say that this is a different stage now, s2n plus 1 divided by n squared. So we're going to divide all of that by n squared. 2n squared over n squared is 2. 3n over n squared is plus 3 over n plus 1 over n squared. This can be treated as a group there. So if n becomes large, what's going to happen? As n becomes large, the denominator divided by a large number will become 0. So we've got then, as n approaches infinity, we have 3 over n plus 1 over n squared approaches 0. So we're left now with 2. So basically we have 2 plus 0. So we can say that the value of s2n plus 1 over n squared with limits of n going to infinity can be said to be equal to 2. And here we are for the full question. Take care.